Okay. So here are the rules. These are taken from your rule sheet. That rule sheet that I gave you, the white one, cream colored paper that I gave you, that has all of the derivatives, right? If you lost it, or if you ever misplace it, or you can't find it, all I did, it's just this page from your book. Here's your book. It's the very first page. That's all it is. Okay. So I took it from there. So we have exponential functions here. How do I know if something's an exponential function? How do I know if something, is this an exponential function here? X cubed. Is that an exponential function there? Is that an exponential function? No. No, it's polynomial, but it's got an exponent. Shouldn't it be exponential? When is it exponential? It has to do what? It has to have x as the exponent, right? Yeah. So if I did this, that one would be an exponential. Okay, so that's how you know something's an exponential. The exponent is the variable. Okay. Okay, so here are these. We're gonna have two different types. The first one is some number to a power, just like we saw, 3 to the x power. Okay. First thing we got to do, natural log of whatever the base is, times itself, times the derivative of whatever the power was. Okay. This one's even easier. E to the u. E to some power. It repeats itself. It always repeats. You see how these guys repeat themselves? They repeat themselves. One of the first things they do is repeat themselves. And then you find the derivative of the function of the power. Okay. E's are one of the easiest things to find derivatives of. They look nasty and they look ugly, but it's really easy because the first step is they repeat themselves and then you take the derivative of their power. Done. Okay. Let's see. Okay, so now log functions. So here's a log and an ln. Derivative of the power, or sorry, of this part here. Natural log of the base times this here. Okay, and then simplify as far as you can. Natural log is even easier. You just take the derivative of here, what it was originally, you're done. Okay. You won't see logs that often. You'll see natural logs a lot. Okay. You'll see natural logs a lot, and you'll see e's a lot, which is good for us because those are the easiest ones to find derivative of. You don't necessarily see exponentials, regular exponentials, and regular logs too often. Okay. Okay, so we're going to focus on the ones that you do see. All right, so the first one, number 1. The numbers are kind of out of order, so don't worry about that. I think around 9 or 10, they start repeating or something, so don't really worry about the numbers. Okay, so the natural log of 4x, we got to find the derivative of. Well, natural log says whatever this is here, I take the derivative of it on top and it repeats on the bottom. Okay. The derivative of 4x is 4. What would be on the bottom? 4x. Can I simplify that? Yes. These guys can cancel out. And I'm left with 1 over x. Done. Okay. All right, do number 2. Okay, so natural log. We take the derivative of the top, 2x. Repeat the bottom, x squared minus 3. Can we simplify that at all? Is there anything I can cancel out? Can I cancel out the x's? Can I do anything else? Nope, done. Okay. Do that one now. Okay, so y prime, take the derivative of the top, 6x minus 5, the bottom stays the same, minus 5x plus 8. Done. Okay. Again, what did I say about natural log? They look a lot uglier than they are. It's not very hard to find the derivatives of them. Try number 4 now. Do number 4. Okay, so this is natural log. This right here is the same thing as natural log x to the 1/2. The only thing to the 1/2 is the x. So you're not going to do chain rule here. Okay, you're not going to do chain rule because it's not the whole thing. If the whole thing was to the x, then you would do chain rule, but that's not the issue. The only thing has a square root is x. So the derivative of the top, 1/2 x to the negative 1/2. The bottom stays the same. So I have a 1/2 on top. I have an x to the negative 1/2, and I have an x to the 1/2. Now you got to use your power rules. Power. How do I simplify these guys here? You can bring it down. That's one way to do it for sure. So if I bring it down, I got x to the 1/2 times x to the 1/2. And then on top, I have 1/2 still. Definitely do that. So what do I do with the powers on the bottom? I cancel them out. Add them, yeah. So 1/4 down here. I can't have a fraction on top of a fraction. It's just kind of bad, a bad look. So this is really the same thing as 1/2 divided by 1 over x to the 1/4, right? It's the same thing as that. Mm-hmm.
Because you're multiplying x to the power of 1/2, the exponents.
Oh, yeah, sorry. Why did I multiply? You're right. So it should be 1 power, right? Power of 1 whole. You are right. Thank you. Yeah, I multiplied. I don't know why I did that. Okay. Keep first one, change, flip. So now you got x over 2. Did I do something wrong again?
You flipped it on the first one.
That's it. What did I do? What did I do here? Okay, so what should it be?
Divided by just x.
Ah, there you go. Thank you. Thank you, like that, right? Yeah, there is no 1, right? Now I flip it here. 1 over x. Done. Thank you. Okay. So again, the hard part there wasn't, I was done with the calculus over here. The hard part is just simplifying it. If it can be simplified, simplify it. Okay. All right, let's see here. All right, this guy here. Do that one. Give that one a shot. I'll give you a few minutes to do that one. So what's the derivative of natural log of x? Just regular natural log of x. Where is it? So let's say this guy was an x here. Let's say this guy instead of a u was an x. So the x goes down here, right? What's the derivative of x? So 1 over x. So yeah, add that, put this in the box too. Natural log, put it right, let's put it right under. So if I just have a plain old natural log of x, it's just 1 over x, 1 over x. Okay. Same thing over here. Let's do the same thing over here. We haven't had any e's yet, but let's say I just have an e to the x power. What's the derivative of e to the x power going to be? Well, what does it do first? It repeats itself. Okay. Times. This would be 1, right? Because the derivative of the power is just 1. Well, I don't need that 1, right? So it just repeats itself. The derivative of e to the x is e to the x. The second derivative of e to the x is e to the x. Okay. Okay, so let's go back over here. Where are we at? Okay, so this guy I got to clean up a little bit. I have x squared over x plus 2x times the natural log of x. So the powers, I can get rid of that power, make it a 1. I can get rid of that one. It's just x to the 0 now. So you have x plus 2x. Can I add the x's together to make it 3x? Can I do this? 3x natural log of x. Oh, why not? Yep. This is the thing right here that makes it like terms. If it has one of these guys over here, sure, do it. Go for it. If this guy had a natural log and this guy had a natural log right there, go for it. Combine them, but they're not like terms because they don't have a natural log of x. So because of that, I'm done. If I can't combine them, I'm done. Okay. Okay. Try this one. Number 6. Sure. Okay. Yeah. So if you're go number 6, do number 6 right now. Oh, how I got the 2x? Okay, so product rule, right? So yeah, product rule. So I found the original times the derivative of the second, and then plus the derivative of the first now, times the original. Yep. Okay. So number 6. Number 6, can you use quotient rule? Yes. Can you use product rule? Yes. Either one will work as long as you set it up correctly. It's right now, it's ready to go for quotient rule. So if you want to do quotient rule, go for it. If you want to do product rule, you would have to move the top. Okay. I'll do it both ways just to show you, you get the same answer. You only have to do it once, but I'll do it both ways. Okay, bottom squared, low times the derivative of high minus high times the derivative of low. Okay. All right, simplify it a little further. If I multiply, I got x over x. This is just going to be x over x. So that's just positive 1. Minus natural log of x times 1 is just natural log of x over x squared. Don't need these anymore since it's just natural log of x. Not wrong if you have them, but you don't need them anymore. Okay. Let me show you how it works in product rule. So I'm going to do in product rule now. In product rule, we take the derivative of, so the first times the derivative of the second. So that one I got to use power rule plus, and then over here, I'm going to do the derivative of the first times the second. Okay. A lot to clean up on this one. So first thing I'm going to do is the natural log is on top. Negative 1 x squared is on the bottom. Or actually the negative 1 should, doesn't matter where the negative 1 is, or you don't even need a negative. You could just put a negative out here because that's all the negative 1's going to do. It's just make it negative. Over here, you're going to have, you have 1x and then you have times another 1x. That's what x to the negative 1 means. Okay. So you have natural log of x over x squared. And then over here, when you multiply, you get x squared as well. Right? I already got like common denominator. Common denominator is already x squared, so that makes it nice. So you're going to get negative plus 1 over x squared. So now the big reveal is, are they the same answer? Is this guy the same as this guy? Yeah, they are. They are exactly the same. Okay. All right, let's see here. Let's pick a good one. These are too easy. Let's skip ahead. So I'm going to skip it. Stop it. Like these examples here, we'll do these, but we'll probably do them tomorrow. I just want to go, I want to do some more natural log since we're in natural log. So I want you to do 7 and 8. It's not really 7 and 8, but I want you to do 7 and 8, these two problems here. Bless you. Bless you. Get your notes, the notes are already on your desk. Okay, so number 7 looks a lot like the one we just did. Number 6 here, it looks a lot like what we just did here. The only thing is they're different. The numerator is now on the bottom, the denominator is now on the top. So how is it going to change our answer? Again, this one here, I would leave like this because you could absolutely do this one as a product rule problem, but then now you're messing with this. You would have something like this, right? And it's okay. It's nothing wrong with it. You could do that, but I just make your life easier. Okay. So now the natural log of x is here minus, look at here, we have the same thing. X times 1 over x is just going to simplify to 1 over the natural log of x squared. Okay. Was that the same answer we got last time? Close, right? The top is 1 minus natural log of x. This one is natural log of x minus 1.
Like crossed out, like because it's an ln x and 2 ln x is on the bottom.
Good question. Good question. So I have 2 of them down here, right? So that means that times itself, right? So this really means the natural log of x times itself, right? So good question. Can I do one of these guys? Can I? The answer is for this one, no. The answer is no for this one. The reason being because of that minus here. Because of that minus, it's connected that way. If this was a times, go for it. That'd work 100%. You'd be fine with that. But because of this minus, this is connected. They're a group. So yeah, if this was -1, go for it. That would work okay. But because of that minus, we can't do that. Yeah. It's kind of like the same idea. If you have something like this, x squared minus 1 over x squared, right? It's kind of that same idea where, oh, x squared and x squared, gone, right? No, you can't because it's not x squared. It's x squared minus 1. It's a different number. Okay. This guy here. The natural log of x to the 5th power. So it times itself 5 times. All right. So this is just a chain rule problem. Move the 5 to the front. You get natural log of x to the 4th power. All right. And then we take the derivative of the inside. Well, what's the derivative of natural log of x? 1 over x. Good. So clean it up a little bit. There you go. Okay. All right, let's do a few more here. Let's skip ahead a little bit. Let's do this one. Number 10. Is number 10 on my paper? I don't know if it's actually number 10. I cut and pasted from different sources, so the numbering's off. So try this one here. Cosine of the natural log of x. So here's the biggest thing I see with students. Is this a product rule problem? Is it cosine times natural log? No, it's not. A lot of students see that. A lot of students see, oh, they see the multiplication, they see the parentheses, and they see cosine in front, and they're like, oh, it's multiplication. So I'm going to use product rule. Cosine's the first one, natural log's the second one, and I'm going to do it that way. This one's not. Be careful here, because if there was an x here, if there was an x in between there, absolutely, 100%, that's a product rule problem. But the cosine, the angle for the cosine is the natural log. That's the angle there. So the angle is the natural log. So it's within the cosine. So this one's a chain rule problem. Okay, this is a chain rule problem. So the outside is this. Okay, so the derivative of cosine, negative sine, everything else repeats. Derivative of the inside, done. Okay, so the steps aren't that hard, but it's just sometimes it's hard to see which rule we're going to use. Is this a chain rule? Is this a product rule? Sometimes those two kind of are confusing. Let's see here. That one's just the opposite. So let's do this one right here. Last one. Last one. Okay, so again, is this a product rule problem? Is it natural log times itself? No, it's not a product rule problem. It's just like the last one. This part is connected with that part there. Okay, because of that, it's a chain rule problem. So this is the outside. So we have natural log of something. I have natural log of something. So anytime I have a natural log of something, it's going to be 1 over, what is it going to be? 1 over x, right? So let's go back here. So natural log is the derivative of what's inside, right? Derivative of that over itself. Okay. This one can get confusing. So I left it for last. Okay, so where are we at? Where am I at? There we go. So again, if this was natural log of x, it would be 1 over x, right? So this part on the bottom here is going to be natural log of x times the derivative of the inside. What's the derivative of the inside? 1 over x. Okay. All right. Okay, so that's where we'll stop today. We'll finish these tomorrow. There's no new assignment. I'll post it tomorrow. And yeah, so we'll continue on with these. So just don't lose this. All right.